In this video, I wanted to discuss the difference between atmospheric and gauge pressure. This is an important distinction you should know before moving on to more complex fluids problems. Because the Earth has an atmosphere, all objects experience pressure pushing on every surface. For example, a person standing at sea level will experience an atmospheric pressure of 1.013 times 10 to the 5 newtons per meter squared. This pressure acts in all directions in the same way that an object submerged in a fluid experiences pressure all around it. This is actually a result of the weight of the air that extends for miles above Earth's surface. As you might have guessed, as the altitude above Earth's surface increases, the atmospheric pressure will decrease. As you move up in altitude, the amount of air above you decreases, which means that there's less overall weight that can contribute to the pressure. In addition, because air is a compressible fluid, its density decreases with an increase in altitude. This also contributes to the decrease in pressure. It's important to note that 1.013 times 10 to the 5 newtons per meter squared is the atmospheric pressure at sea level. This will vary slightly with changes in elevation, but it's often a good approximation for anything close to Earth's surface. This can be written as 101.3 kilopascals, which is equal to 14.7 pounds per square inch, or psi. The atmospheric pressure at sea level can also be simply written as 1 atmosphere, or ATM. For certain measurements, it's not always intuitive to write things in terms of atmospheric pressure. For example, the gauge that measures your tire pressure will measure things in terms of gauge pressure. This measurement represents the difference between atmospheric pressure and absolute pressure. We can say that the absolute pressure is equal to the gauge pressure plus the atmospheric pressure. For example, if you fill a tire to 40 psi, this actually represents the gauge pressure. This means that the pressure inside of the tire is 40 psi greater than the atmospheric pressure pushing on the outside of the tire. Since we know that atmospheric pressure at sea level is 14.7 psi, the absolute or the actual pressure inside the tire will actually be equal to the sum of these two quantities. This means that in this case, the absolute pressure inside the tire is equal to 54.7 psi. I hope that this video clearly explained the difference between atmospheric and gauge pressure.